Hello, everybody. Welcome to Calaveras Big Trees State Park. My name is Lily. You can tell I work for the park because I have this handy dandy patch here. We like to say that the bear is our boss. And of course, I'm wearing the classic hat. And today we're going to be talking all about the things that live here at Calaveras Big Trees State Park and how they handle the winter time. We're going to stick inside the Calaveras Big Trees Museum. I'm going to show you some of the cool things we have in this museum. And we're going to focus a lot, of course, on the giant sequoia and how it handles the wintertime, as well as the various animals that live here and how they survive the wintertime. We're going to talk a lot about their superpowers, also called the adaptations. So first off, I want to give you all a bit of an idea for where I am in the state of California. You can see on this Google map here, I have labeled Calaveras Big Trees State Park. We're not on the very tippy top of the state. We're not super far north, but we're further north in places like LA, all that. We're not very close to the coast either. We're much more inland, and we're kind of by the border of Nevada. Now, we're not on the border, but we're kind of close. And that actually means that we're in the Sierra Nevada mountain range. We're not the tippy most top of it. We're not way up there, but we're pretty high up there. We're at about 5,000 feet, which means that we at Calaveras Big Trees can get a pretty intense winter. Not always, but we can. Because we're way up there, we can have things like cold and snow and all that. Now, I just said a couple things, but I want you all now to go ahead and think about winter. What do you think of when you think of winter? I'm going to step aside for a minute here. Go ahead if you want to. You can pause and think about winter. Go ahead and have at least a couple people think about it. And you can write it down or you can speak it out loud to each other. All right, so hopefully you all were able to discuss it more. Feel free to pause it again if you want to do a bit more of talking about it. But winter you think of winter can bring up a lot of thoughts and ideas, right? I already mentioned there's cold, there's snow. Maybe you think about Christmas time if you celebrate that. Maybe you think of different like winter animals or hot chocolate. There's a whole big variety of things you might think when you think of winter. A lot of those things are what living things have to deal with the wintertime, especially the cold and the snow. And they can't just go inside, light a fire, and stay cozy warm. And they can't just put on a big old jacket, a nice puffy parka maybe, and walk outside and feel okay. They have to live through it, which means that they have to have certain adaptations in order to live through it. So feel free now amongst yourselves, talk about what is an adaptation. Go ahead and do a little pause if you want to talk about it, because I'm about to say what an adaptation is to me. An adaptation is any characteristic a living thing has to help it survive and thrive. By that I mean it's going to make it through some of the tough times specific to that environment it's in. So like up here, make it through things like maybe a lot of snow or some cold. And by thriving, it's going to do pretty well. Maybe it's going to have a bunch of kids. Maybe it's going to live a long life, something like that. And there's always a characteristic it has to help it with that. So for humans, our thumbs are a great example of an adaptation that's helped us survive and thrive, because we can now grab onto things. We can use tools. And we can live almost anywhere and do okay. So the first living thing we're going to talk about that has some adaptations for the wintertime is, of course, the giant sequoia. Now I keep touching this behind me. This is a replica Giant Sequoia in our visitor center. All right. And the cool thing about the Giant Sequoia, besides its winter adaptation, is that it's the biggest living thing to have lived. Okay. So I want us to just think about that for a bit. Visualize the biggest dinosaur you've ever seen in a book or heard about or saw in a museum. It's bigger than that. Think about a really big tree that maybe you saw somewhere. Unless it itself was a giant sequoia, the giant sequoia is bigger than that. It's bigger than a blue whale. It is absolutely ginormous. I'm going to give you a bit of a visualization here, and I'm going to show my screen with some cool facts. So my wingspan, that means from my fingertip to my fingertip, is about 5 feet. All right. The widest giant sequoia is over 30 feet wide, which means it would take 6 of me holding my own hand to stretch all the way across the widest giant sequoia. They're really big across, but they're also really tall. That's where it gets the claim to fame. It's both really wide and it's really tall. The tallest giant sequoia is over 300 feet tall. That means I'm a little over 5 feet. Pro tip for you, your wingspan from fingertip to fingertip is about the same as your height, usually, not always, but usually. And I'm about 5 feet, a little more than that. If I stood on top of my own head, it would take 60 of me to reach the top of the giant sequoia. They can be over 300 feet tall, right? Those are massive trees. Now, I will say giant sequoia is not technically the tallest tree. That goes to its cousin, the coast redwood, that's on this map right here. Now, I like this map because it includes some pretty cool information and also shows you the ranges of these trees. So the coast redwood is that bright kind of orangey red color that goes along the map there. It mentions the tallest tree, be more than 370 feet tall. So it does beat out the giant sequoia, but it's nowhere near as wide as a giant sequoia if you add it all up together. The coast redwood, hence the name, likes to hang out along the coast. The giant sequoia, I mentioned before, I'm in the foothills of the Sierra Nevada. I'm not at the tippy-most top, but I'm kind of still in the mountains, just not way up there. They like that range, and they only live in that range. That bright lime green circle there, that's where I am. And you can see the kind of orangey yellow color that stretches down from that. That's where the giant sequoia live, and that's it. They're very picky. That biggest bright color on the bottom, that's where the biggest giant sequoia lives. It's in Sequoia Kings Canyon National Park, and it's called General Sherman. And it is massive. It's wide, it's tall, it also weighs literally tons. It weighs more than 640 tons, which is far more than 100 elephants. It's wild. But I like to think critically about these things, okay? I just said it's really big. And we're going to talk about how it has some winter adaptations. How did it get to be so big? How can it be so big? Well, they grow just like we grow. And they need certain things to grow. So, those needs have to be met before it actually can get really big. It needs the 3 things plants need for photosynthesis: carbon dioxide from the air, water, and sunlight. It also needs good nutrients in the soil, a nice location for it to get really big and strong. It also needs a lot of time to get big and strong. The giant sequoia can be over 3,000 years old, and they don't stop growing. So for us, we can't be that old, of course, but some of us might get into 80s and 90s, but our height's not going to change depending on how long we can live. We'll usually stop growing in your teens and 20s, and that will be it. I'm going to be about 5'3" for the rest of my life. The giant sequoia just keeps on growing and growing. And I'm going to show you a bit of a timeline here I made to give you just an idea based off of human history, how old is 3,200 years old. So the oldest giant sequoia seed fell from the cone onto the ground and started growing during the Egyptian Empire. All right. We think about that as ancient history. But that's just when this one giant sequoia was alive. And it was still living and growing through the Romans, through the Vikings, through when all those famous paintings were painted like the Mona Lisa during the Renaissance. And it's still living and growing today. That's how they can get to be so big, because they can be so old. But, you know, that answer brings up another question. How can they be so old? They've had to go through so much to be 3,000 years. A lot of things can happen to a giant sequoia that can kill it, including an intense winter. So now we're going to bring that back all around. I want you to remember what you thought when you thought of winter. And we're going to talk about what the giant sequoia needs, what adaptations it has to have to survive the winter. Now, a lot of these adaptations, or a few of these adaptations, have to do with the bark of a giant sequoia. This. All right. This is a real sample of the bark of a giant sequoia. You can see it's a nice red color. I gotta tell you, it's also pretty soft. I don't think I'm gonna get a splinter, or I'm pretty sure I'm not gonna get a splinter by stroking this. It's also very lightweight. That's important. The giant sequoia bark has a lot of air pockets in it. Just like the air pockets inside a really cozy, warm, puffy jacket, like a parka jacket. Same idea. If you have lots of air pockets in something, it helps trap in heat better. It helps insulate better. Which means the air pockets in here that act like a nice parka jacket are going to keep the tree warm enough so their insides don't freeze. If their insides froze, and the tree would die, and there'd be lots of issues. But the bark protects the tree from that. And not only is it full of air pockets and really nice and kind of fluffy in its own way, it's really thick. The bark of a giant sequoia can be over 2 feet thick. All right. That's a lot of warmth. You can imagine if you're outside and it's like 10 degrees or something, and it might be super cold, but you have a parka jacket that's 2 feet thick, you're going to be okay. And some scientists even say that the bark can be over 3 feet thick. That's a lot of bark. And that's a lot of warmth. And that's really key for its survival. So we covered how it has to deal with the cold. Now let's think about how it has to deal with snow, but also one other thing that, at least when I've talked to other people, they don't always think about when they think of winter. This is not the first gut thing that they say. Winter has a lot less sun than the other seasons. You can think about it. You're going to school, you're going to work, you're doing whatever. You might wake up in the morning in the wintertime and it's still dark. You might be on your way to school or work and it's still dark. And then you might be done with school, only have maybe an hour or two, 5 o'clock, it's dark. You might be off from work and it's dark again. In the summer and spring and fall, there's just a whole lot more sun. And that impacts plants like the giant sequoia. I said before, right, 3 things it needs photosynthesis. We got carbon dioxide, don't really need to worry about that. But we also have sun. If there's less sun around, there's less of that necessary ingredient for the tree and any other plant to photosynthesize, to make its own food. So that's an issue. Also, sure, some of y'all mentioned snow. Snow is water that's locked up. And like, you can eat snow, right? I've done that before. Maybe you've done that before. But you don't drink snow. plants, they need to drink water. They can't eat it like we can. So there's less of it available if it's freezing the whole winter through. So they have to plan ahead, and they have to think about that sort of thing. So what they do, they literally make more food ahead of time. When there's enough sun, enough water, they make a ton of food. If they don't use it all at that time, they then shoot the food, which is sugar. They shoot the sugar down to their roots, and then they store it in their roots for later when they might need it. It's just like if, let's say, you have a cousin that has a lot of tomatoes. You're probably not going to eat all the tomatoes they give you at once because there's just too many of them. So you might freeze them. You might make them into a giant pasta sauce and toss that in the fridge. You're going to do some sort of storage, if you can, of that food so you can eat it later when maybe you don't have the food you want or the food you need. You plan ahead, and so does a giant sequoia. So those are two cool winter adaptations. One is the bark. We mentioned that has two important components to make it a whole lot better for the winter time. It's kind of soft and puffy, like a parka jacket. It's also really thick, so it keeps the tree warm enough so it won't freeze. We also talked about how it plans ahead and stores food in its roots because there's less sun and sometimes less water in the wintertime, at least if the water is locked up in things like snow and ice. So now's a great time, if you want to pause again, to go ahead and discuss those things. Maybe try to brainstorm what other winter adaptations you might have seen in other trees. While you do that, I'm going to flip the camera around and give you all a few seconds to think about that. Okay, so hopefully you're all now back. So as I said, to flip the camera around, we're now going to talk about the animals that live here and their winter adaptations. So I'm going to just give you a nice little panorama of the rest of our little museum here. I've quarantined off, so it's just me in here today. And we're going to get a nice up close look at all these animals here. Now I'm going to introduce you to them. Now these are all animals that were once alive and now they're taxidermied, but they're pretty sensitive. You might see there, might go backwards for you. It says, please don't touch us. I'm not going to touch these, so I'm going to get the camera kind of close so you can get a good look at them. So we have first right here, the coyote. And we have the fox. Now, both the coyote and the fox are relatives of dogs. So that might look a little similar to a dog you might have at home. You can see back there behind the coyote, that's a porcupine. We have up here a bobcat, one of the few felines we have, one of the few cat relatives we have. We have, of course, the bear. Now you can see that there's two bears here. They're actually both black bears. Not all black bears are black, which is a little confusing, but they can be shades of tan and brown. In California, we only have the black bear. So you're pretty much guaranteed to see a bear as a black bear. We have a skunk. We have a snake right there. We also actually have a snake right there by the skunk itself. A couple different snakes. We have this owl right here. You can see, let me get that like that it is going after the poor rabbit. But everything has to eat. That's just the way it goes sometimes. And then we have up here a mountain lion. Now, all these animals, if you happen to see them in the wild, even kind of simple, or maybe not simple, that's kind of harsh, even ones you might have seen before, like a squirrel, all of these animals, you see them in the wild, especially in the park, you want to leave them alone. They're wild. You don't want them to get so used to humans are going to come up and like beg for food, because especially if something like a bear does that, that can be pretty dangerous and people can get hurt. So we always want to respect the animals wherever you are. So let's talk about some of these animals and their adaptations. I'm going to start with kind of the classic example of adaptations in the wintertime, the bear. Bears are pretty famous for their winter activities or their non-activities. They just sleep in the winter. Now, not all bears sleep the whole winter through, but a lot of them do. And it's called hibernation. Think about hibernation. So they do it because they realize, hey, there's no real point of me being up and around right now. It's really cold and there's not a lot of food for me to eat. So might as well just sleep. So the bears find a nice cozy place to have their den. Maybe it's a tree that's fallen over, a nice little crack in the wall somewhere. It might be something as simple as just like a little overhang on a cliff. You get in there and then they hibernate. And then they can hibernate again for a short period of time and like wake up, move around, and go back to sleep, or for a long period of time. In general, the more harsh the winter, the more sleeping without waking up the bear goes through. Now, if something sleeps for a long period of time, that means they're not doing the basics, right? They're not eating. And that's actually an issue right there, just not eating. Bears could starve, but they don't. At least not if they can plan ahead, kind of like the Giant Sequoia does. Bears, and this is pictures of brown bears, also called grizzly bears, they know to store a lot of food ahead of time before they hibernate. So they can get super fat. Now these pictures here are of two bears, Bear 151 and Bear 480 at Katmai National Park in Alaska. You can see just about 2 months later, they go from really skinny to pretty fat. And this actually is from something called Fat Bear Week that Katmai National Park does every September. If you want, you can go online and they can vote for which bear you think got the fattest. And then whichever one wins is crowned the Fat Bear of the Year. It's pretty fun if you want to participate in that. But these bears eat thousands of calories a day just to get super fat. So they can sleep for a very long time and not eat. They just use up all the fat that they have stored. It's a pretty smart way to do it. One other thing they don't do when they're sleeping, it's kind of gross, but they don't use the bathroom. They can actually keep inside themselves their poop and their pee. And if their body needs to, their body can somehow use that waste that's stored inside them and recycle any sort of extra water or nutrients that are in there. It's wild. But that's their adaptation. That's their winter survival technique. They say, look, it's really cold. There's not a lot of food. So I'm going to eat as much as I can, sleep as much as I can, and be super efficient. Be really good about using all the nutrients and water and everything else that I have in my body already. Pretty wild. Now I'm going to give an example of kind of the opposite of that winter adaptation. We're going to talk about what snakes and other cold-blooded animals, like other reptiles and amphibians, do. So I'm just moving the camera here so I can get a closer look at the snakes. In the display here. So we have right here a rattlesnake. Maybe you can see a little rattler there. Now over here we have the king snake. Now I said snakes, cold-blooded reptiles, amphibians. But what exactly do I mean by all that? Well, all reptiles and amphibians are cold-blooded, which means that their insides can vary in temperature. It all depends on what the outside temperature is. So if it's really hot outside, their insides are pretty warm. If it's really cold outside, their insides are pretty cold. Now, we as humans, we're warm-blooded, so that means that our insides are always warm. It's kind of helpful because that means that we're okay if it's really hot, we're okay if it's really cold, our insides are still going to be the same. But that does mean that we have to eat a lot of food all the time in order to keep that up. You're basically adding fuel to your inside fire to keep you nice and warm. Snakes, being cold-blooded, they don't have to eat all the time. Pro-con, though, that means when it's really cold, their insides are cold and they can't function, they can't move, they can't really do anything. So often what reptiles do, like snakes, is they kind of hibernate like bears, but it's more of a forced thing. If it's below about 50 degrees, they're just kind of stuck where they are. So often they like to hang out in a little den of sorts, kind of like the bears. This is a picture of some lizards I found online. So not snakes, but they're both reptiles, they're both cold-blooded. But all these lizards were kind of hanging out together when it was really cold, so they have protection in numbers because they can't really move. But because they're cold-blooded and they can't move, that also means they don't need to eat all the time. So snakes don't have to worry about stocking up on food like the giant sequoia with its roots or like the bear with its fat. It's okay to just hang out, not really move a whole lot because it's too cold, because they don't need to eat, not as frequently as we do. It's a very different kind of adaptation. It's kind of one that has to do with their whole way of living. Now, one extreme example of this, it's not an animal we have in the park, but I think it's really cool, so I like to talk about it. One extreme example is something called the wood frog. Again, they're cold-blooded, but they can literally freeze into a block of ice, survive for however long the winter months are, 3 months, 4 months, whatever it is, and then thaw out and they're okay. They have some crazy inside body functions that allows that. We can't do that, we would die, but they can. And scientists are actually looking at that to try to figure out, can we use this to help humans out? Like maybe if someone's really sick and the medicine isn't available, can we like freeze that person until the medicine is available and then let them thaw out? Who knows, right? It sounds very science fiction, but it is a real thing that animals can do. So again, pretty wild. It's a pretty cool winter superpower, winter adaptation. Now we're going to switch a little bit here, not talk as much about food and how to survive like the lack of food in the winter, but just how to survive in general in the winter. We're going to talk right here about the rabbit. So again, here we have an owl going after the rabbit. You might notice this rabbit, kind of a tan brown color, but it blends in pretty well with the ground we have here. The kind of brown that has bits of pine needles and things like that. Now in the wintertime, the ground often isn't brown. It's covered in snow, right? You might have thought about snow as one of the examples of what you think of when you think of winter. So if the rabbit is still brown and there's a white snow, that means it's really going to stand out. And a predator like an owl can pretty easily go after it. So what rabbits do, and a lot of the other small mammals that don't hibernate, the rabbit just changes its coat. It sheds its fur, just like our hair sometimes sheds. And then it grows a different colored coat. So when it's fall and the sunlight starts to change, so when it's fall and there's just less and less of that sun, something triggers inside the rabbit. It sheds its brown coat and it grows a white coat. And then when the sun starts to come back in fuller force in the spring, again, something is triggered inside the rabbit and it sheds its white coat and grows in a brown coat. It's pretty cool. And it's all about camouflage, blending in with the environment so then something like an owl can't find it as easily. So it can survive. And it does do things like store extra food ahead of time and all that, but that's pretty unique to the rabbit. And again, to other small critters too. So we got the bear, we got the snake, we got the rabbit. Let's talk about another one. Let's talk about birds. So birds have a couple options here. They can do a pretty big variety of things. Well, more than a couple, right? We just saw the owl. The owl's a bird. In the wintertime, the owl's a predator. So as long as prey like rabbit are still around, it's going to stick around and it's going to be okay. What the owl might do, and what some other birds do, kind of like the rabbit, it can shed its feathers. That's called molting when it's feathers. It loses its feathers, then it grows back some that are a lot warmer. I didn't mention this, but that white coat to the rabbit is often warmer and a bit thicker, so it can withstand the cold, just like the giant sequoia bark. You can see they're all connected. So birds grow warmer feathers. Maybe they stick around like the owl to go hunting for rabbits. Maybe they stick around like the woodpecker here, which has the red on top of its head and the black and white. Might stick around because it's storing lots of food in all these holes you can see in the tree here. By the way, we have a squirrel on the tree. That's what the squirrels are doing too. They're storing food for the winter. So if you see lots of squirrels digging up your garden or digging up somewhere else and storing food, they're just doing that so they can survive. Might be a little annoying, but that's just what they're doing. But we have food storage, we have warmer feathers, and then we have one other thing. We have migration. So some birds, like songbirds, they like to eat things like berries or insects, and both of those might not be around. Berries, it's just not the time of year. Insects might go into some sort of hibernation, kind of like the snakes do. So if those aren't around in the wintertime, the birds that eat them, they peace out. They just leave. So this I'm showing you right here is a migration map. The different colors correspond to where birds go within that color. So for example, in California, we're in that blue section there. The birds that live here that rely on all those food sources that are just gone in the winter, they often just leave. They might travel for thousands and thousands of miles down to somewhere in South America. And they want to go all the way down there because it's a different season. The northern hemisphere, where we are on the upper part of the map, whatever season that is, it's the opposite on the southern hemisphere, down where South America is. So if it's winter up in California, it's summer down in some place like Chile. So birds know that. And so they're like, you know what? I'm just going to chase the summer. I'm just going to go from summertime, turning to fall, flee down to what might be spring, then it's summer, and then it's fall, and they go back and forth. Some birds can be really extreme about it and travel great distances because of this. Other birds, though, may migrate, but it might be more of a minor migrate. So like the quails we have up here, they're up here in the summer, but in the winter, they don't travel thousands of miles, but they might like run down the mountain and go to someplace a little bit warmer. So there can be a variety in the migration. But the birds are really intelligent and know how to plan for this. They know the route through generations. They know where they might make some good, important stops to eat some food. And lots of birds, if they migrate really far, they have these really incredible wings that are designed to catch the best air and not have to flap all the time. So they can save their energy. And sometimes they even sleep while they're flying. It's not the kind of sleep we're used to. Sometimes it's like half of their brain is asleep, another half is awake. It's really strange compared to what we're used to, but they can do that and fly at the same time. So they have some pretty wild ways to deal with the winter by simply not dealing with it, by just leaving. Now, we've covered a lot so far. Now I'm going to throw it to you all. I want you to go ahead. Let me not actually stand over here. The lighting's not great. I want you to go ahead, grab a piece of paper, and think about all the different superpowers we talked about. So we have the giant sequoia with its fluffy bark that's also thick. It stores food in its roots. We have the bear that hibernates sometimes for months, but also gets super fat, so it can do that. We have the snake that's cold-blooded and can just kind of hang out because it has to, but it doesn't need to eat. We have the rabbit that changes its coat. And we have the birds that can get warmer feathers, can just store food, or just leave. Think about all of those, and I want you to go ahead and design your very own winter superhero. If you want to combine all those different superhero, all those different adaptations all into one, that's fine. You can pick kind of your favorite, but go ahead and draw that out, or you can write it out if you prefer, and kind of get creative with it. Because there's so much cool stuff, so many cool traits animals have to help them survive the wintertime. So I want to thank you all for joining me today. I hope you learned at least a little something. And again, my name is Lily. I'm with Calaveras Big Trees State Park, live from the Visitor Center. And I hope you have a wonderful day. Bye-bye, everybody.